Hello everyone, welcome back to my channel Math Smart Tips. Today in this video we are solving a question from GATE 2022 Mathematics, question number 56, which comes from linear algebra. The question says that consider R3 as a vector space with the usual operation of vector addition and scalar multiplication. Let x belongs to R3 be denoted by x equal to x1, x2, x3. Define the subspaces W1 and W2 by W1 equal to x belongs to R3, x1 plus 2x2 minus x3 equal to 0 and W2 equal to 2x1 plus 3x3, this is equal to 0. Let dimension of U denote the dimension of the subspaces U. Then which of the following statements are true? Here it is note that the question is MSQ, that is multiple answer type question. So more than one options here is correct or are correct. Now the concept behind the question is here, let we know that let VF be a vector space, let VF be a vector space and W be a subspace of V, then it says that dimension of W, this is equal to dimension of V minus number of linearly independent restrictions. This, so this is the concept behind this question, and here the vector space V means R3. So we all know that dimension of R3 is equal to this vector space, so this is equal to clearly 3, and given that W1 equal to, so it is given that W1 equal to this x belongs to R3 and x1 plus x2 minus x3 equal to 0. So W1 equal to dimension of R3 minus number of linearly independent. Here it is here only one restriction, so which is clearly linearly independent, so this is minus 1. So this is equal to dimension of R3 equal to 3 minus 1, this is equal to 2. So dimension of W1 equal to clearly 2. Now the second one is W2 equal to this 2x1 plus 3x3 equal to 0. Now again dimension of W2, this is equal to dimension of R3 minus here only one linearly independent restriction in W2, so this is clearly also minus 1. So this is equal to 3 minus 1, this is also equal to 2. So dimension of W1 equal to 2 and also dimension of W2 is also equal to 2. So here the option 1, it is the dimension of W1 equal to dimension of W2 and this is equal to 2. So option A is correct here. Now option B says that dimension of W1 plus dimension of W2 minus dimension of R3, this is equal to 1. So dimension of W1 equal to 3, dimension of W2 dimension of W1 equal to 2, dimension of W2 this is equal to 2 minus dimension of R3 equal to 3. So this is equal to clearly 1. So option B is also correct. Now dimension of W1 intersection W2 and dimension of W1 plus W2. So here the formula to find the dimension of W1 plus W2, this is equal to dimension of W1 plus dimension of W2 minus dimension of W1 intersection W2. So we have first find this dimension of W1 intersection W2. Now W1 intersection W2 means, so what is W1 intersection W2? So dimension W1 intersection W2, this is equal to x belongs to R3, this is equal to x belongs to R3 and both the conditions are hold. So x1 plus 2x2 minus x3 x1 plus 2x2 minus x3, this is equal to 0, and the second restriction is 2x1 plus 3x3 equal to 0. So 2x1 plus 3x3, this is equal to 0. Now both these two restrictions are clearly independent restrictions. There is no linear dependency. So dimension of W1 intersection W2, and also it is noted that W1 intersection W2 is a subspace of R3. So dimension of W1 intersection W2 equal to dimension of R3 minus number of linearly independent restrictions. Since these two are linearly independent, so minus 2. So this is equal to 3 minus 2, and this is equal to 1. So dimension of W1 intersection W2 equal to 1. But here, so this option is also correct. Dimension of W1 intersection W2 equal to 1. So D option is also correct. Now we check the whether this C option is correct from this formula. So dimension of W1 intersection plus W2 equal to dimension of W1 means 2, dimension of W2 means 2, and dimension of W1 intersection W2, this means this 1. So 2 plus 2 minus 1. So this gives 4 minus 1 equal to 3. But in option C it is given that this is 2. Therefore this option is not correct. Therefore the correct option for this problem are A, B and D. These three are the correct option for question number 56. So how was the video? If the video is helpful, then please give a like to this video, share with your friends and subscribe to the channel. Thank you friends. See you again in the next video. Thank you.